Okay, all right. So if you got this done last time, just see if you got this right. So what you want to do is you want to set u equal to that part there. And the reason I know to do that is because if I can end up with a u to the 8 integral, then that's easy. Antiderivative of u to the 8th is u to the 9 over 9. So you're always trying to turn this into a real easy integral. So you wanted to set that equal to x to the 6 plus 2. Okay? And what you're trying to do on this is du is just the derivative. You don't even want to look at the integral until you've done du. So the derivative of x to the 6 plus 2 is 6x to the 5th. You do want to tack on the dx because that's an important notational aspect of that. Okay? We tried to kind of get started on the u sub that are a little easier, and notice that 6x to the 5th dx matches what's left. That's what you hope happens. Okay, if that happens, then it's a pretty simple problem to do. So what you would end up with is you replace the x to the 6 plus 2 with u. So you do have u to the 8th. Okay, just doing that. And then the 6x to the 5th dx gets replaced with du. That was your goal, was to turn it into something easy. Okay, so we worked really hard on doing a lot of antiderivatives in the last class. So now that's u to the 9th over 9. Plus c, you always have a plus c when you're doing this. And then the last step is you do not want u in your answer. You want x to be in terms of your original variable. So the answer I hope you got was replace u with x to the 6 plus 2. That'll be raised to the 9th over 9 plus c. Okay, is that what we got? I don't know if anybody had time to finish that up because we ran out of time in class. Now I want to show you, you don't need to write this down. But remember, if you check your answer, all you got to do is just take the derivative of this. And if you take the derivative of this, that's a chain rule right there. So you'd bring down the 9. You'd have x to the 6 plus 2 to the 8th. You would multiply by the derivative of what's inside, which is 6x to the 5th. And then that 9 is a constant. Okay, so you don't do anything with the 9 just because it's a constant. Notice the 9's cross out. And then if you compare that to the original problem, you're back to the beginning, aren't you? So you have the power to tell you right on this, okay? You got the power, all right? Okay? All right. I guess, I don't know if, did anybody have time to do the second one or not? I think we kind of ran out of time. Do you all have any thoughts about what I should set u equal to? 14 minus 1. How come? Okay, it's got a variable in it. What is the derivative of 4t minus 1? 4, okay? That's what you're looking at. But that's fine, okay? So we're going to go ahead and let u be 4t minus 1. Okay, so we've got that part kind of taken care of. And then the derivative of 4t minus 1 is 4. And then tack on the dt. Just think of dt at this stage in the class as notation. And again, that's what we hoped happened. That's what makes this kind of the easier type of integral to do. Everything matches up, okay? So what we're going to end up with is you replace the 4t minus 1 with u, and then the 4 dt is just du. And that du, it doesn't matter where it is. The du is always off to the side. It's never in a denominator. You could either put it in a numerator of a fraction or way off to the side. Now this right here, the way you would want to do this, is we ended up with an integral that's very easy to do. So what's the antiderivative of 1 over u? ln u plus c. Good. Okay, so we end up getting ln, absolute value of u plus c. You always have to have absolute value to guarantee that you're taking a ln of a positive number. And then what's the last step? Plug back in. The u goes back in. It's kind of like the chain rule in a way when we learned the chain rule. So the final answer to the problem would be this. Again, you could take the derivative of that answer. You can do that in your head pretty easily and tell that you're right. Because if you did the derivative, you would have 1 over 4t minus 1 times 4. Okay, so that's the right answer. Okay, all right. So any questions on what I'm doing so far? Okay. Now, on your test that we do next Tuesday, these are the kind of u sub I'll test over, okay? I'm not going to do the test over what I'm going to teach next here. I won't do that until the final exam. Oftentimes, students need a little time to practice this. I've kind of changed the way I taught this over the years, and I'm going to teach it just this way this semester. It's going to be a little bit different than what I've done in the past. And this will be a technique. If you just follow this technique, it'll always work, okay? I think it takes some of the thought process out of this then. So step one is to figure out what to set u equal to. In this problem, we're going to let it equal to 1 minus 4x to the third, okay? Because if we end up with a square root of u, well, we can handle that. You could change that to u to the 1/2, and then you could do the antiderivative. You want to end up with something that you can do. Now, don't look at the integral, just do du. Du is the derivative of u, so that would be negative 12x to the second, and then you tack on dx. Okay, so here's what makes this problem different. That did not match. Every problem that we did prior to this example, they matched perfectly. So they do not match, so here's what you want to do. If that happens, just solve this equation for dx. Okay, then everything will work its way out of the problem nicely. Okay, so I'm going to take this equation. You can do this in your head, actually, if you want to, so you don't have to show this step. So I'm going to divide both sides of this equation by negative 12x squared. And then that will give what dx is equal to. So I'm going to say dx is du over negative 12x squared. So if they don't match, just immediately solve that du equation for dx. Okay? Now let me show you why that works. Now when you substitute everything in, here's kind of how this goes is like this. All right, first of all, this is going to be u. Okay, we know that u, that's what we set u equal to. So we are going to have square root of u. Okay, now this dx, you're going to replace that dx with what you just solved for. So that's just kind of off at the side. That will be du over negative 12x squared like that now. Okay, now you have to substitute in for everything. So the only thing I haven't substituted in for is 2x squared. So simply bring it down. Okay, so you just basically substitute in for u and substitute in for dx. Okay, you guys with me so far? Okay, now when we do this integral, we don't want x to appear in this integral, but don't the x squareds cancel out anyway? That's what'll happen, okay? These problems are designed so that will happen. So cancel those things out. So now you've got the integral. You really have 2 over negative 12, and I'm going to change that u, the square root, to a 1/2 power like that. Now, if you do this technique, but because of the type of integrals we focus on this class in, that'll happen. You'll get a cancellation. You always want to end up with an integral that just has u in it. Only that. Does that make sense? Yes, no, tell me. U sub's kind of weird when you first learn it, yeah. Okay, that came from this substitution right here. So remember, I solved this equation right here for dx and got this, and then that plugged in for dx. Well, I'm not sure. Okay, so when I substitute in, so I did the derivative of this to get negative 12x squared. That's what du is, okay? Then what I did is that became u, right? Dx became this, and then I left that alone. Okay, does that make sense?
Can you explain the integral part, the substitution of u?
How I substituted to get this whole thing?
Yeah.
Okay, all right. So this thing right here is what u is, because we set that equal to u. So that became square root of u. Okay, that's usually the easy part. Okay, now, when I did du, you always do du by doing the derivative, and it did not match. Okay, so if it does not match, take this equation and solve it for dx. So that's why I divided both sides by negative 12x squared. to get dx by itself. Now, dx is a substitution. See, that dx, you just replace dx with that whole thing, so that gives you this. Okay? Now, I didn't do anything with 2x squared, just bring it down. And the reason we do that, because you're going to have that cancellation anyway.
Why we don't cancel the 2?
We will. We can reduce that fraction down to 1/6. Okay, which we will do that. Okay? All right.
Why do we substitute 12 for negative 12 due to the 1/2 instead of 1?
Well, I changed the square root to a 1/2 power because that's how I'm going to do the antiderivative, right? We know the square root of u is the same thing as u to the 1/2. So all I did on that is just change that to that so we can do the antiderivative. What we're going to have to do in the next step is bring that up so it becomes u to the negative 1/2, then we can do the antiderivative. Okay, you guys with me? Okay, it'll get better each time I do a problem, it'll get better. Okay, at least that's the hope. All right, so you can go ahead certainly and reduce this fraction. I could have done that, at any time, so I can just take that. Now what I'm left with is I've got the integral of, and I've got really just 1/6. I have a negative. You can put that negative anywhere you want to. And then you can bring this to the top to make that u to the negative 1/2 du like that. So now you're ready to go through and do this integral. Now there's a couple of steps that are optional. I did teach you all last time that you can bring a constant out of an integral. So you can do that if you want to. You don't have to show that step. You can just write down the negative 1/6 anyway. So now what we do is we write down the constant. When we do the antiderivative, remember we did this last class, what do? You add 1 to the exponent. So we're going to add 1 to that exponent. Then we're going to divide by that result. The result of negative 1/2 plus 2/2 is 1/2 like that. Then we got the plus c. Okay? Now, what we got to do from here is not much. We have negative 1/6. Okay, what do I do with that 1/2? Because I'm dividing by a half, what are you really doing? Multiplying by 2. Dividing by a fraction is the same as multiplying by the reciprocal, so you can write that as times 2 over 1. Then you've got u to the 1/2 plus c. Now you're ready to wrap it up and get the final answer of the problem after all this, okay? So what happens with this is, yeah, you could reduce this 2/6. 2/6 reduces to 1/3. And then you would have just negative 1/3. And then you can just plug back in your u. The u in this problem was 1 minus 4x to the 3rd plus c. So that would be the answer to the problem. The only difference on this problem is when you did dx, it did not match. And if it does not match, solve for dx, then plug in. Okay, that's just the one technique that I'm going to teach you how to do in this class. Okay, is that at least okay? Somewhat okay? Okay, it'll get better. Like I said, it gets better every time you look at a few more examples and then start working them out, it'll get better. Okay, U-sub is kind of a challenging thing a lot of times to learn. Okay, so let's go to the next page and we'll look at the same kind of things that happen. Okay, what are your thoughts on u? What do you think? 10x minus 3. Okay, we're going to let u be that part. Okay, so that's 10x minus 3. Okay, what's du? 10 times dx. You do the derivative. Remember, du is the derivative of u. Okay, now what you do is kind of say, okay, does this thing match what's left over? I'm trying to use colors on this so you can kind of see how these things are matching. So there's no match. So what did I tell you to do in the last problem? Solve for dx. Good. Okay. So we're going to take this equation. You can do this in your head. You don't have to show steps on this. You can divide by 10. So what you get is you get dx is equal to du over 10. Okay. So I got u, got du, solve for dx. Any question about that? Okay. So I think what students struggle with a lot of times is getting everything substituted in for. Okay. So what do I replace 10x minus 3 with? U. What do I replace dx with? Du over 10. okay? And that leaves us with a 1, but that's okay. All right, we can do this integral. This is an easy integral. So what you end up getting is you have 1/10 times 1 over u, if you want to write it that way. So that's really what you have. You have a 10th, and the 10th is a constant, so it can come out in front of the integral. So we have 1/10 times the integral of 1 over u du. Okay, what's the antiderivative? ln, good. Okay, so we get 1/10 ln of absolute value u plus c. Okay, and what's the last step? Plug in u. Okay, good. So u, we wrote down what that is. You just plug it back in. So you're going to have 1/10 ln absolute value 10x minus 3 plus c. Okay, you could do the derivative of that. If you do the derivative of that, it'd take you back to the original problem. Okay, I want to just kind of show you how you could do this in your head, because you get really good with this kind of stuff if you get the answer and you try to check as much as you can in your head. So if you checked, you would bring down the 10th. When you do the derivative of a log, we learned to do 1 over the function and then times the derivative of what's inside. And see what happens is the 10s cancel out. They work their way out of the problem. So that's why it's the right answer to the problem. Okay, does that make sense? You don't have to check, but it sure is good to know how to do that. You know, like on a test or something, you can tell you're right. Sometimes students tell me they don't want to check on a test because they don't want to know if they're wrong. They're afraid they're wrong. It's good if you find out if you're wrong, then you can fix it. Okay, all right. Any question on that? Okay, all right. Okay, let me try go through one more, then I'll let you try to do a few of these and just kind of see how that works for you. Okay, so what do you think we ought to do with u on this problem? Probably that whole denominator. Now, a lot of times, sometimes you're going to choose wrong. You have to, try to get as much in there as you can. And let's just try this. Now, what I'm thinking is the derivative of x to the third is 3x squared. So we want that x squared to pop up. The derivative of 3 is just a constant, so maybe we can get that to match with that 1 somehow. But sometimes when you're learning this, there's a little bit of trial and error. Okay, so tell me what du is. 3x squared minus 3 times dx. Don't forget that dx there. Okay, so now the next thing is kind of see does this match the rest? It doesn't. Okay, so what we're going to do is we're going to do the same thing we did on the previous two examples. We're simply going to solve this equation for dx, and you can do this in your head. So you can just divide both sides by 3x squared minus 3. So you get du over 3x squared minus 3 is equal to dx. Okay, so we set u, we got du, we solve for dx. Any problem with that? Okay, why am I solving for dx? Because they didn't match. Okay, theoretically, you could do the simpler problems this way too. If you wanted to, you could just do them all this way if you want to. Okay, so now the substitution part is what's hard for students, I find, when they're learning this. So what do I do with the denominator? What does that become? That becomes u. Okay, what does the dx become? Right, okay, so dx, don't replace dx with du over 3x squared minus 3. Okay, now that leaves us with one other part of the problem, and you just bring it down. The x squared minus 1, you just bring it down. Okay, everybody okay with that? Okay, well, we got to get rid of those x's. Okay, if you can't get rid of those x's, then you're doomed. Okay, any thoughts on what I could do? You can take a 3 out. Okay, exactly. Okay, and again, these problems are designed so that you can do stuff like this. So just bring that down. Now you can take a common factor of 3 out of the bottom. This part right here, just factor out the 3. And okay, when I made this problem up, I designed it so this would happen. If that doesn't happen, like I said, you can't do it. Okay, so now we can cross that out. All of the problems you're going to do are the x's are going to work their way out of the problem. Okay, so you should end up with something that's fairly easy. So really what I have is, I have a third right there, and that you really have a third right there. That can come out of the integral, and then you're left with 1 over u times du. And that du, just always have that du at the side. Don't worry about whether it's in the numerator or denominator. It's just out there at the side. It's notation. But I have a 1 over u, and I have a 1/3. Okay? So what's the antiderivative on this? ln of u again. Okay, got that. Kind of works out the way the last problem is. And then the last step is to take the u and plug it back in. Okay, so what we're going to have is, for our final answer, 1/3 ln x to the third minus 3x plus 7 in absolute value plus c. Now that problem could be checked pretty easily by doing the derivative. If you know how to do the derivative with the chain rule on that, you could get it pretty easily. Okay, so what we're doing now is du does not match. So if it doesn't match, what did I tell you to do? Solve for dx. Okay, that's the key. All right, any questions? Okay, so I'll let you try. I think we'll do this, 2 problems. Okay, if you can get these, that kind of gets you off to a start on these ideas then. Okay, and I'll walk around and see if you need some help. That I had to help you with, it's the substitution step that you're having the most trouble with. So again, with this one, you're going to let u be x to the fourth plus 16. du is just the derivative, so that's 4x to the third times dx. Okay, so the key thing is the 4x to the third dx does not match what was left. Okay, that's what tells you need to solve this equation for dx. Okay, so we got to do that. And what you end up with is dx equals du over 4x to the third. Okay, so I think that part right there was mostly okay. I'll tell you what was not okay with a lot of you is when you substituted in, you sort of forgot about that x to the third. Okay, what you end up substituting in for is the part in yellow becomes u. So this part right here becomes u to the 6. Everybody had that okay. dx turns into this, so that becomes du over 4x to the third. But you got to make sure everything's accounted for. So there's always going to be some little piece left over, and then the variable x is going to work its way out of the problem. That's the substitution. Are you guys okay with the substitution now? Okay, that was the hardest part, was that. Now we have this, and now what we're left with is we have u to the 6 over 4. There's a lot of different ways to write that. You could write that as 1/4 u to the 6, and du is just way off at the side. Just make sure that's way off at the side. And again, you can bring out the 1/4 because constants come out of integrals. Okay, like that, and just keep bringing everything down, and keep bringing du down until you're done with your antiderivative. So the 1/4 comes down. Antiderivative by the power rule is u to the 7 over 7 plus c. Now du disappears. Now it does, okay, because you're done with the integral. It's just like if you do 7 plus 3, the plus sign disappears because the plus sign tells you to add. The du tells you to integrate. It's the same principle. So you end up getting 1 over 28, and then you plug back into u, so your u was x to the fourth plus 16 plus c, so that's the answer you got. Now, some of you also wrote your answer this way, which is also okay. Doesn't make a bit of difference to me. It's both right. Doesn't matter which way you do it. It's up to you. Okay, so the whole key to these problems, of course, is choosing the correct u and then getting all of your correct substitutions. And what will happen is the original variable will cancel out. If it doesn't, you're doing something wrong. Okay, that's the way it's going to work. Okay, now like my Calc 1 class, we do a little bit different twists on this problem that you all won't do. These are the things you're going to see. Okay, so number 2, you should have set u equal the bottom. Okay, that way you've got that taken care of. And then du is the derivative, so that's 10t. Most common mistake is students forget about the dt. You're trying to keep track of your notation. So again, what happens is that doesn't match what's left over. And since it doesn't match, that's when you solve for the dt. Okay, so we're going to divide both sides by 10t. So you're going to have du over 10t is equal to dt. So what you have is you have this substitution right there and this substitution right there. Okay, and then you're going to have something that's kind of left over. So in this problem, replace 5t squared plus 2 with u, replace dt with du over 10t, but don't forget about the 20t. That's what's going to work its way out of the problem. Okay, so if you get that substitution on your paper and get to a point where you can do that effectively, then you got it made. Okay, that's what most of you were having trouble with, was getting that everything substituted in for. Now, did the t's cancel out? Yeah, I told you, they always will if you're doing it right. Okay, and again, 20 over 10 is 2, so you really end up with 2 over u times du. Okay, now think of it this way. 2 is a constant, so it comes out, and you're left with, a lot of times students, I see stuff, they don't know what's left over. It's 1 over u, okay? There's got to be something in the numerator, so it's 1 over u. Now, the antiderivative of 1 over u, I can tell everybody knows, is ln u plus c, okay? And see, now's when the du disappears. I did the antiderivative, now it's gone. Okay, you won't have a du in your answer, you will have a plus c. And then last step, plug back in the u, so you'll have 2 ln, absolute value of 5t squared plus 2 plus c. Okay, that's your answer. Okay, what do you think? Okay, you can do it, okay. That's probably as difficult as the integration we'll get in this class. Okay, and like Calc 2, when I teach that, it gets pretty dang complicated. But that's as far as we take integrals in a class like this. All right, I am going to go through and do these differential equation examples. Then we'll take a break. And then the very beginning of this, I skipped the very beginning because last class I wanted to get you started on this. I was afraid if I didn't get you started, it might be. And the differential thing is pretty easy, so I'll go back and do that. But let's go ahead and do these problems. So this problem right here is giving you a derivative, and a differential equation, we talked about that last class, is an equation that has a derivative in it. So your goal on this is to find the original function that has this derivative. The first step that I recommend you do on this is this. Okay, so just write down your derivative, and this is what I suggest that you do. What you want to do is multiply both sides by dn. That's the same thought process of you got an equation with a fraction, get rid of the fraction. Okay, so let's write down, we have dm, which represents the derivative of the function m, and then you'd have left 10n times n to the second minus 8 to the 7th times dn, like that. Okay, so now what we're going to do on step 2 is this is where we're now going to do the integral. Okay, we do the integral of both sides of the equation. So we do the integral of dm equals the integral of 10n n to the second minus 8 to the 7th times dn. Okay, that's kind of separating the variables. That second integral needs to have nothing but n's in it. Okay, so that's a good place to start, is that then. Okay, the antiderivative of dm is m, okay, because the derivative of m is dm. Okay, that's what we wanted in the first place. So what we would have to do is we would have to do this integral right here, and that's u substitution. How do you know it's u substitution? There's no rule that I taught you that you could simply do that integral in your head. There's nothing. So you have to do u substitution. Okay, so we're going to focus on this integral right here. And let's think about u. So what do you want me to set u equal to? N squared minus 8 is a good thought. Okay, so let's let u be that piece right there. Okay, so we know that's going to become your u right there. We're going to end up with u to the 7th. Okay, now the next thing is when we do du, what's du? Times what? dn, okay, like that. Now notice that 2n dn does not match up with 10n dn. They're close. They're off by a constant, and that's what's going to happen on these problems. Always they're off by a constant. So what we've been doing in this case is go ahead and solve that equation for dn. So you're going to get du over 2n is equal to dn like that. Now if you can get this substituted in, then you'll have everything okay. Okay? All right, so here's kind of what happens now. So we know that we're going to plug u in there. What are you going to replace dn with? du over tn. This, I kind of wrote that kind of sloppy. That right there should be du over dn. Okay, we got that. Okay, what am I going to do with the 10n? Nothing. It's going to work its way out of the problem. Okay, so when you get everything substituted in, bring down the 10n. This will become u to the 7th. Then the dn becomes du over 2n. And that's the way all these problems have been working out. The original variable cancels. The 10 divided by 2 is 5. So you end up with the integral of 5u to the 7th du. Okay, you end up with that u variable. This u variable is just an intermediate variable. The goal is to turn it into an easy integral that you can do in your head. That's the purpose of this. Okay, now you can do this in your head. 5's a constant, it comes down. The derivative of u to the 7th, antiderivative, is u to the 8th over 8. And then you got plus c. Again, that's when the du disappears because you've done your antiderivative. So you end up getting on this problem then 5/8 u to the 8th plus c. And then the last step would just be to plug the u back in. And the u was the part that I have in yellow here. So you would have 5/8 parentheses n to the 2nd minus 8 to the 7th plus c. Last step is just plugging back in to get that original variable. That's your antiderivative. So that's the answer to this differential equation, is m is equal to 5/8 n to the 2nd minus 8 to the 7th plus c. Same idea. Okay.
Minus 8 to the 8th power?
What?
We added 1 to 7, so 8.
So the final answer would be n to the 2nd minus 8 to the 8th power?
Oh, to the 8th. Okay, I don't know why I did that. I think what happens sometimes you do a problem like this, you look at the wrong previous step. Okay, pretty clearly it's u to the 8th right there. Okay, all right, now we got it. Okay, all right, any problem with that? Okay, it's just kind of applying what we just learned. Okay, all right, I love this little cartoon I found on, math teachers love this. So when you grade a test, like your test you're going to do next Tuesday, make sure you have plus C when you do an antiderivative. Students are very bad to forget about that. So someone suggested just give students a stamp. So when they're doing their homework, they always go plus C, plus C, plus C. Don't forget it. I take a half of a point off if you don't have plus C. It's not a big penalty, but it's enough to tell you that you need to do it. Okay, hopefully, all right? So in this particular problem right here, we've got this is enrollment. Now this is a rate of change of enrollment, and it's a differential equation because it has dE over dt. So it has a derivative. Okay, so go ahead and just write that down to begin with. And then the first thing you want to do is kind of get this thing set up. So we have dE over dt equals 5,000 times t plus 1 to the negative 3 halves, like that. Okay, just like the last problem I did, the first thing you ought to do is just get rid of the dt, multiply both sides by dt, and now what you have is you have dE equals 5,000 times t plus 1 to the negative 3 halves times dt, like that. Okay, so that's how you start the problem. You want your e's on one side and your t's on the other. That's just dt's on the other side. So when you get to step 2, you're now going to do the integral of both sides of this equation. Okay, and if you want to, you can either leave the 5,000 in the integral or you can take it out. I'm just going to take it out. That's a personal choice. You don't have to do that. So I've got t plus 1 to the negative 3 halves times dt, like that. Oops, not du, dt. Okay, all right. So what I'll be looking at here now is this is a u substitution integral. I'll show you in a minute that you could do this particular integral without u substitution. But we're going to go ahead and do this by u substitution. So that part right there is going to be what your u is going to be. The antiderivative of dE is e. It's the opposite. Okay, if you have a derivative of e, well, the original function's e. Okay, now what we're going to do on this integral is we're going to let u be t plus 1. So what's du? 1 times dt. So it's really just dt. Okay, the derivative of t plus 1 is 1, so we have that. Now, the nice thing about this problem is this. Does this match what's left? Yeah, it does. So you don't have to do that thing I just taught you. So sometimes they match, sometimes they don't. Okay, so this one matches. So now all you got to do is just get everything plugged in. So you have 5,000, and you have your integral of u to the negative 3 halves. And then dt is du, because du just turned out to be dt. So you get that. Okay? So we've got that as put together now. All right, does that make sense so far? Okay, all right, now we can get our antiderivative. So we can do our power rule. So again, you're adding 1 to the exponents. You're going to do negative 3 halves plus 2 halves, divide by the result. The result of that would be negative 1/2 plus c. Okay, so we worked on, that power rule quite a bit in the last class, so we have that. Okay, what do I do with that negative 1/2? Multiply by the reciprocal, right? If you divide by negative 1/2, that's the same as multiplying by negative 2 over 1. So what you're going to get is E equals 5,000 times negative 2 over 1, or just negative 2, times u to the negative 1/2 plus c. And then you're ready to kind of put this together and plug the u back in. Okay, so we get E is equal to, and then 5,000 times negative 2 would be negative 10,000. U to the negative 1/2 plus c, and then we can plug that back in. You could skip this step too and just go ahead and plug that back in. Okay, so u in this problem was t plus 1. I always kind of highlight what my u is in yellow. It's just the way I teach that. So this would be the end of the second step. You've got that's called a general solution to the differential equation. We're not done with the problem because this has got a couple of more things involved in it. But that's the antiderivative part right there. Any question about that? Okay, now, we learned this last class. What you have is it says the enrollment is 2,000 when t is 0. So in your third step, you're going to actually find what c is equal to. You've been given enough information to do that. So what that says is it says if t is 0, then the enrollment is 2,000. That's what the problem says. So you need to plug those numbers in and then solve the equation. So we're going to have 2,000 is equal to negative 10,000 times, and that would just become 1 to the negative 1/2 plus c. Okay, so I'm taking that information, plugging it in. We can solve that equation for C pretty easily. Okay, the nice thing is 1 to any power is 1. Okay, you don't have to work that out. 1 to any power is 1. So you can just kind of cross that out if you want to. So we have 2,000 equals negative 10,000 plus C. Now what we do is just add 10,000 to both sides. You can do that in your head if you want to. I'm okay with you doing that last step in your head. So you would end up getting C equals 12,000 like that. And now we're ready to write that final answer on this. This would be the final answer to that integral. So all you do is take the answer I got boxed in at the bottom of the page, and you just write E is equal to negative 10,000 times t plus 1 to the negative 1/2 plus 12,000. So the 12,000 plugs in for C. That's all I did. I gave enough information on that to figure out what C is. Okay, we did that last class. Does everybody understand what I did? Okay, one more part of the problem. This is the easy part. Now it says, find the enrollment in 15 years. So what do you think you do? You plug 15 in for T, exactly, okay? So what we're really going to find, kind of like in the last step of the problem, is you're really doing E of 15. So yeah, you just take that final answer you got, which is right here with the 12,000, and you do negative 10,000 times 15 plus 1 to the negative 1/2 plus 1,200. This could be done by hand, but I'm just going to do this on the calculator. You can type this all in pretty much in one step, and then you would get what this new enrollment is then. Okay, so I'll just put this in. Negative 10,000 now times parentheses, and that'll end up being 16 raised to the negative 1/2. I'm not going to change that to a positive exponent. And get down the exponent plus 12,000. And there's our answer. So our answer is 9,500 would be our enrollment. Okay, so that's oftentimes what happens in practice is sometimes it's easier to measure a rate of change than it is an original function. So if you can measure a rate of change, you can work backwards to get the original function. That's the idea. Okay, good problem. Okay, now that kind of thing, you will do what we call these initial value problems on your test on Tuesday. You won't do one with U sub in it, though. So the ones that I did in the previous section are a little bit better examples stuff. So first of all, the idea is you've been dealing with integrals now, and it's this mysterious dx thing. Ultimately, that's going to represent, eventually, a rectangle, the width of a rectangle. And what's really going to happen on this is going to be the height of a rectangle, and that's going to be the base of a rectangle. And I'm not going to show you that today, but ultimately that's what that's going to be. It turns out that dx really represents an infinitesimally small number. And so what I want to kind of get you, and I've already really got you kind of used to doing this by doing the integrals, is the idea kind of comes from here. So if you have the equation, and I want to kind of jump down to this stage right here, it says you know that dy over dx equals f prime of x. I mean, you know that. All that is that's two different ways to write a derivative, right? F prime of x is one way, dy over dx is the other. So they mean the same thing. So what you can do on this, you could take this equation and you could multiply both sides by dx, and then that would cross that out. So what you end up getting is you get what's called a differential for y. You get dy is equal to f prime of x times dx. Now that's why that dx technically shows up in an integral, okay? Because you have you're doing an antiderivative of a derivative and then dx. It just simply comes from that thing right there. So we're going to look at just focusing on this part right here, that if y is equal to f of x, then dy is equal to f prime of x times dx. Okay, that's what I'm going to focus on. I'm not going to do part one of that where we're talking about that it's a real number until next week. So what I'm going to show you is going to be quite simple, actually. Okay, so what I'm doing is I'm giving you a function on this example one, and you're finding dy. It's not much different than what you did on U substitution. So doing dy just simply means do the derivative of x to the third, which of course is what? 3x squared. But you got to tack on the dx. That's what I taught you to do in your U substitution integrals anyway, was that, okay? You just got to know how these variables are going to line up. Okay, the next problem, you're given this function, and you're going to find du. So all that really means is do the derivative of this function that's solved for u. So how do you do the derivative of ln 4 minus x squared anyway? 1 over the function, then what? Derivative of what's inside is a chain rule, so the derivative of what's inside is negative 2x, okay? Now, since x is our variable, we tack on dx. So we just write the answer as du is equal to negative 2x over 4 minus x squared times dx, okay? So this is kind of what I was really showing you to do in U substitution without any real explanation. It's still not a good explanation until we get into the application of what's called a definite integral that we'll do next week. Okay, so this one is the same thing. Okay, we're going to do the derivative of this function that's solved for v. So remember, when you do this, how do you do a derivative of e to the negative 6t? Itself, then what? Times the derivative of the exponent. The derivative of negative 6t is negative 6. And then this time, don't put a dx, put a dt. The reason you put dt is so it matches the variable. So what you would get is dv is equal to negative 60 e to the negative 6t times dt. Okay, that's how you get that differential dv. Okay, and let me show you something on this. You don't have to write this down, but you know, maybe to help you understand this a little bit better. I mean, what we're doing is not hard, but if I divided both sides by dt, all I'm going to get is what you're used to seeing anyway. You're going to get the derivative dv with respect to t is equal to that derivative. That's all it is. It's just writing that lower part of that Leibniz notation on the other side of the equation. That's all it is. And that's really all I'm doing in this problem. Okay? Okay, so I'll let you do these 3 problems real quick and see how you do. Shouldn't be anything to that. And then we'll start talking about test review stuff. The first one, you're just doing the derivative. So what's your derivative? 3x squared is 4x plus 1. And then what did you put? Times dx. You don't have to put a dot for times. You can just put dx like that. Okay? What's your derivative on the next one? Itself times what? 2t minus 2. That does need to be in parentheses. If you didn't put the 2t minus 2 in parentheses, fix that problem. It's got to be in parentheses. Okay? Otherwise, you're not writing that algebraically. Then what else did you have? D what? dt. Just make sure you have the same variable. That's the key. Okay? And then the last one, well, the derivative, I don't know why I put y in parentheses, but that derivative would be 4y to the third. And what do I put next to it? dy. Okay? That's it. Okay? So really what's happening on that is it's a way of writing notes, splitting up the notation. So in a sense, what we really have is du over dy is 4y to the third. That's the way you're used to seeing that written, but you can move that over there by multiplying both sides by dy. That's all it is. Okay, that's the idea. Okay, any problem with that? Okay, let me close off this